My mathematician for today will be Archimedes. So autobiography. So Archimedes was a Greek mathematician. He was born in Syracuse, Sicily, in Greece. Uh, he was born in 287 BC and passed away in 212 BC. I'm not 100% this is accurate because some sources were saying in the area of 280 to 290, in the area of 212 or 211, but this is the most accurate one I could find. There wasn't too much about him in his past life. As they said, the only person who wrote a biography on him was one of his close friends, and his name was Hercules. But as time went on, the biography that was wrote on him was actually lost. But one thing they did know was that his father was an astronomer named Phidias, and that they had a friend. As far as schools go, since it was so far back, then there wasn't many universities. So he studied at a school established by the Greek mathematician Euclid in Alexandria, Egypt. He was a man of many trades. He was not just a mathematician. He was a mathematician, a physicist, an inventor, and many more. He made a lot of impacts in many different ways. He invented screw pumps, compound values, and sieve machines, and he also derived many theorems and help us get closer to what the approximation of what pi is, and that is what I'll be walking you guys through today. So, to get an approximation of pi, he became close using something called the method of exhaustion. So I will be proving how using the method of exhaustion, using his form, can get us to the area of a circle, which is a equals pi r squared. So first we're going to consider a circle with the radius r, of course, and we're going to inscribe it inside of a regular polygon with n sides. And once you do that, for the area of that circle, it will give us the equation an equals 1/2 times the radius times p of n. So p of n is just a regular polygon, and the n represents the number of sides in the regular polygon. So as n increases, the regular polygon is going to get closer to, it's going to approach the circumference. And with that approaching circumference, so we want to solve this and put it into a different form. So we are going to rewrite p of n as n times s of n. And s of n is just all the sides that are inside of the polygon, and they're all going to equal the same thing because it is a regular polygon. So to find s of n, we have to divide the circumference into equal parts. And when you divide them into equal parts, each one would equal 2 pi over n radians. And once you do some trigonometry that I couldn't find that they did, you will find that Sn would equal 2r times sine pi over n. So now that you have these two values, you would just simply plug back in. So you would just plug that back into p of n, which would give you n times 2r times sine pi of n. And then you would just plug p of n back into a of n. So now a of n is 1/2 times r times n times 2r times sine pi of n. And then you can just reduce that, so you know the 1/2 and the 2 will cancel out, and then the r's will make r squared. So therefore r squared n sine pi over n. So now for a of n, to figure out what the area of the circle will be, as n increases for the for a, that is the closer you are approaching. As n increases, you're approaching the area. So we're gonna make this become a limit as n approaches infinity. So we're gonna go a equals of this equation. Now, one thing to know is that as n approaches infinity, sine of pi over n is just going to simplify to only pi over n. So then you're left with a equals and then you can cancel out your n's, and then you're left with a equals pi r squared, which is the area of a circle in modern day. So for his contributions to math, as I just showed, he got us to the closest approximation of what pi would be without actually using pi, as they use the top formula. And most of the other contributions he made also went towards modern day calculus, and mainly it went towards integrals. And then his post studies, after he finished, he went back to living in Syracuse, Sicily. And while he was there, he normally tended to the king and all of his problems. So one of the most popular things of him is his story of Eureka, where when he was tending to King Harold about one of his issues, he believed that he asked a craftsman to make a crown for him, made of gold. He gave him all the gold to make the crown. But the king believed that the craftsman kept some of the gold and only used partly gold and then used partly silver to make the crown. So he asked Archimedes to figure out if the crown was full of gold or not. So one day, Archimedes, when he was thinking about the situation, he was going to take a bath. So he stepped inside the bath water, and once he stepped inside the bath water, he realized the water displaced each other and basically like made a mess on the ground and everything. And from that, he came up with the idea that maybe if he puts the crown inside of some water and see how it displaces, it would displace differently depending on the mass or what is made from the material. So that is called Archimedes' principle. So that was one of the things that he came up with in his later days when he was tending to the king. And he's